Hey calculus kids, this is Dr. Callahan with week 7 Tuesday. I hope you guys had a great weekend and also with Monday off. So go ahead and pause the video and answer the following 3 questions. Make sure you guys have your guided notes so that way you turn over to week 7. It's going to be under Monday. I know it's Tuesday, but it's under Monday. So week 7 Monday in your guided notes. All right, let's go ahead and create the assignment for today on MS Team for those guys who are on a hybrid model. So week 7, Monday, I should say Tuesday, AP Calc, AP, semester 2. Our topic of discussion today is going to circulate around integrals of arctangent, sine, cosine, and also arc trig functions. I know that sounds kind of scary, but I really try to pretty easy way of assigning this. So make sure you guys check in with me. By second period, which is at 9:41 a.m. So that ends at 9:41 a.m. That's also when I'm going to be taking your attendance. Make sure you guys check in with me before then, and then your assignment must be inserted by 3 p.m. the same day because that's when your grade will be going in. So I'm just go ahead and click on assign, and let's go ahead and get started with today's stuff. So the breakdown of today is going to look like this. We have already talked about integrals and derivatives of a to the u power, etc. We're kind of moving past that. I will do a quick little review with you guys, and then we're just going to jump right in on integrals of arctangent, arcsine, arccosine, and arctrig functions. All right, so let's go ahead and turn over to your guided notes today, which looks like this. And you guys actually have, there's actually a bit of them. So there's 7 pages. I know you're like, what? 7 pages? So here are the derivatives for arctangent and then also the formulas that you will need for that. This is page 2, page 3, page 4 on additional examples, page 5, which is going to be a card activity that we're going to be working on. And then this is going to be your guided notes for the arctangent or arctrig functions that we're going to be talking about. But before we jump into that, I want to do a quick little review on derivatives and integrals of a to the u and e to the u to make sure that you guys are good and copacetic with that before we move forward to new topics. So with that said, I'm going to have you guys turn over to this page right here. Go ahead and fill in the blanks of the formulas. You need to make sure you memorize this and you have this in by memory because as you know, you do not get the formula sheet when you guys are doing this on the AP exam. All right, so you guys know that the derivative e to the u is just a u to the u, pretty simple overall, times u prime. And then of course, integral of e to the u is just e to the u plus c. So this is important to see it simultaneously side by side. The derivative of a to the u is going to be ln a times a to the u times u prime, okay? And then the integral of a to the u is 1 over ln a times a to the u plus c. Okay, so now that you have those formulas, take a look at example 1 to example 6. Pause the video and try that to see if you're able to get them. All right, so here are the answers for examples 1 and 2. They're pretty straightforward overall. There's really not much that is really required. It's just simple memorization of the formula itself. I'm going to go ahead and go over example 3 with you guys. With this one, it requires a little bit more work. You are going to have to do a u substitution, obviously. And also what I want to do is I want to modify this so I have the formulas right here. So that way you can see them specifically what the formula will be equal to. So just give me a second. Let me go ahead and screenshot this, and I will paste this over to the work that we're going to be doing right now. Okay, so let's go ahead and take a look at example 3. So with example 3, as you can see from here, you probably want u to be tangent x because you know the derivative of tangent x is going to be a secant squared x. Whereas if you let u be secant squared x and the derivative of that, I mean, how are you going to go ahead and cancel out the tangent x? You know what I mean? So before you actually start wasting time, figuring out what u is going to be, kind of look at it as a forethought to see what it could be and how you can cancel things. So u is going to be tangent x. Derivative of u is going to be a secant square x dx, and then the dx is a du over secant squared x. There we go. And know that the integral that you're using is going to be for this formula right here. And let me just make sure that I'm actually sharing this so you guys can see this. Okay, perfect. Nothing makes me more upset if I go through the entire thing and then realize that the screen share was on a different screen and you guys have no idea what I'm talking about. All right, so let's go ahead and move forward with this. Let's rewrite it. Integral 5 to the u secant squared x. Replace your dx right here with a du over secant squared x. And look, you can go ahead and cancel that out. So you have the integral of 5 to the u power du. There we go. So now let's go ahead and apply the equation. If I match this equation up, you know that your 5 is going to be your a, and then your u is going to be your tangent x, okay? So then here we go. Integral of 5 to the u is going to be equal to 1 over ln a, so 1 over ln a is going to be 5, times a to the u, so that's 5 to the tangent x plus c. And that right there is going to be your answer. All right, let's go ahead and take a look at example 4. With example 4, you want to ask yourself, what do you want your u to be? If you let u to be 3 minus x, the derivative of that is just going to be negative 1. So that negative 1 is not going to help you cancel out your 3 minus x squared because you'll still have, even if you replace it with a u, you still have a u squared. You know what I mean? So let's say, let u be 3 minus x squared. Your du is 2 times 3 minus x, the 1 power, times the chain, which is 3 minus x. So the derivative of 3 minus x is just a negative 1. So then your du is going to be a negative 2 times 3 minus x dx. So then let's go ahead and find dx, which is just going to be du over negative 2, 3 minus x. All right, let's go ahead and rewrite this. Integral 3 minus x is going to give you just 3 minus x right here. So you just want to keep it as is. All right, 7 to the u. Replace your dx with the du over negative 2, 3 minus x. And look, your 3 minus x cancels, which is great. You can move your constant outside of the integral, 7 to the u du, which is perfect. Now, you know that your a is going to be 7, your u is going to be 3 minus x squared. So then the integral of this is going to be a negative 1/2 times 1 over ln a, which is ln 7, times a, which is 7, to the u, and that is 3 minus x squared plus c. And that is your answer. Now, if you want to go ahead and rewrite this and make it look a little bit better, what you can do is you can go ahead and put like a negative 1 over 2 ln 7. I mean, it doesn't really change it much. 7, 3 minus x squared plus c. So this one works as well. All right, let's go on to the next example. Okay, so 5 and 6. So for example 5, you want to take a look and see which formula are you going to be using. It is an integral, so there's no e, so obviously we're probably going to be using the same formula that we had before, which is right here. Okay, so then looking at this, okay, you have a big task here. It looks really ugly, and you want to go ahead and get it so that it's in a form of integral of a to the u, but there's a lot of stuff going on here. So first thing, let's figure out what you would let x be. Or I'm sorry, let u be. I would probably recommend the denominator part, which is 5 minus 7 to the 2x squared minus 5. So then that way you know that your du is going to be 0 minus let's see. Sorry, I'm like looking at this going, okay. So the derivative of 5 is a 0. Now the derivative of this one, you guessed that, I mean, you can't just bring down the, the chain rule. You can't bring the 2x squared minus 5 in front of the 7, because then you, I mean, you can't have that. That just looks ugly and hideous. So with this one, you're going to have to use, oops, let's go ahead and erase that. So with this one, you're going to have to use the following. Okay, so with this piece, okay, gosh, what is going on? Change that. So with this piece right here, you're going to have to use a derivative of a to the u. So I know that looks really messy, but let's go ahead and see where it leads us. So then you have to have a, which is 7, u, which is 2x squared minus 5. In the formula, you see how there's u prime. Your u prime is going to be 4x. And so let's replace the derivative. So ln a is going to be an ln 7 times a, which is 7, to the u, and that's 2x squared minus 5, times u prime, which is a 4x, dx. So then if I were to solve for dx, I will have a du over, that'll be a negative ln 7, move the 4x to the front, 7 to the 2x squared minus 5. Okay, as I'm looking at this, okay, it doesn't look great, but it doesn't look horrible either, because if I rewrite this right here, I will have the integral of 7 to the 2x squared minus 5 over u, replace your dx, and don't forget there's an x right there, so I'm going to put the x right there, replace your dx with du over negative ln 7 for x, 7 to the 2x squared minus 5. So then let's go ahead and see what we can cancel. We can cancel the 7. That's gone. I can cancel the x. That's gone. And then I'm left with 2 du on top. On the bottom, I have a negative ln 7 times u, which is fine because ln 7 is actually a constant, and so you can move that in the 2 to the left side of your integral, and you just have 1 over u du. And if you remember, what is the integral of 1 over u? Yeah, you guessed that. The integral of 1 over u is equal to ln u plus c. So then my answer is negative 2 ln 7 ln u, and remember u was 7, or excuse me, 5 minus 7 to the 2x squared minus 5 plus c. And that is your answer. All right, go ahead and pause the video and take a look at example 6 and give that a try on your own. Okay, and here is your answer for example 6. Okay, so now what I'm going to do is I'm going to take a look at the right side of this. There are some additional questions that you can go ahead and answer, and then here are the answers for them. So just pick a few randomly, see where you are, make sure that you know how to do this. All right, I'm going to go over example 6 from that series of 12 questions, I think. So let's go ahead and take a look at this one right here because it is a definite integral. So with this one, I'm looking at this and I'm thinking maybe I have to use the a to the u again, but we'll see which integral we're going to be using. So with this one, let's let u be. I need to get rid of this x right here, and you know that the derivative of ln x is 1 over x. So perhaps there's a chance that I will be able to cancel that. So I'm just going to say let u be ln x. So then du is 1 over x dx, and then dx equals du. How do you get rid of the 1 over x here? You will have to go ahead and multiply x on both sides, so just be x du. Now let's go ahead and rewrite this. Here's the integral from e to the 4th, 5 over x times u to the 1/2. Replace your dx and you'll have an x du. And guess what? It was perfect because this part will cancel, which is great. I can move my 5 over to the outside of this. And then I have just 1, or actually I can bring that u up to the front du. And I actually don't have to use any of the rules here. And instead, it'll just be a simple reversal power rule. So minus the 1 over, or actually 2 over 2, which is a negative 3 over 2, divided by the negative 3 over 2. Make sure you flip that, which will give you a 5 times a negative 2/3 u to the negative 3 over 2 plus c. Replace your u with whatever you had before, and that was an ln x. And you're going to evaluate it from e to the 4th. So we're going to have to do a little bit of a side work right here because e to the 4th is not just like, like your traditional normal numbers. This one requires a little bit of work here. And hold on just a second, minus. Oh, you know what? I made a typo here. You can't minus 1. I got derivatives and whatnot confused. You're supposed to be adding it, sorry. So that's incorrect. So that's 1 over 2. So this will be divided by 1 over 2. There we go. So then when you divide it by 1 over 2, you have to flip it, which would be a 2 over 1. There we go. So technically that will just give me a 10 ln replace that with a 1/2. ln to the ln x to the 1/2 plus c, evaluate that from e to the 4th and e. Okay, so then on my side work here, this is what I'm going to be doing. You know you're going to be plugging the e and e to the 4th. So if x equals e, then ln e is going to be equal to, what is ln e? It's just 1 because they cross out each other. If x is going to be e to the 4th, then ln e to the 4th, you want to plug it into your calculator, is going to give you a 4. So you're going to be using these two right here. So let's go back to this. So here I have 10 times ln e, because I'm putting up the upper bound first, okay, e to the 4th. So ln e to the 4th was 4. So I'm going to have a 4, don't forget your 1/2 to the 1/2, minus, here's your lower bound, 10 times ln e, which is going to give me a 1 to the 1/2. So with your calculator, what's 4 to the 1/2 times 10? That's going to give me a 20. And then what is 1 to the 1/2 times 10? That's going to give me a 10. So my area that's underneath this curve is just going to be 10. And that's my answer. All right, so that was a review. So now let's go ahead and talk about your arctangent, arccosine. So I know it's more derivative rules to memorize, but it's actually not that difficult. You don't need to memorize it. You could do this a different way. It's just like the simple geometric way, and I'm going to show you the easy way versus the hard way today. So let's turn over to this page. Go ahead and read this. You actually don't need the formulas for this, although if you want to memorize the formulas, it might be easier, but I'm going to show you the hard way of doing this, kind of like the back alley way of doing this without utilizing the formula. All right, let's go ahead and make sure you guys remember this, okay? Sine, remember, is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. Trig inverse functions, cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. So then if I were to go ahead and find the cosecant theta, it's going to be opposite of sine. So instead of having opposite over hypotenuse, it'll just be hypotenuse over opposite. Secant is going to be opposite of cosine, so hypotenuse over adjacent. Cotangent is going to be adjacent over opposite. And then secant squared is just 1 over cosine squared x. Excuse me. Okay, so let's go ahead and take a look at example 1. Find the tangent given that the arced cosine is a square root of 2 over 2. This is a review, okay, from trigonometry. So I went ahead and labeled the steps for you guys. Now, for the tangent of the angle whose cosine is square root of 2 divided by 2, remember cosine is adjacent over hypotenuse, so let's go ahead and draw this. Here's your little person right there. This is the perspective if you're looking at it. Opposite, hypotenuse, adjacent. You know that your adjacent is going to be square root 2. Your hypotenuse is going to be 2. And so what is your opposite going to be? Remember, you have to use a Pythagorean theorem, so it's going to be square root 2 squared plus opposite squared equals 2 squared. So then your opposite is going to be the square root of 4 minus square root of 2. Square root 2 squared is going to be a 2. So opposite is obviously going to be just a square root 2. So now that you have these 3 labels and length and measures of the 3 sides of the triangle, let's see. Done with step 1, we labeled it, Pythagorean theorem. Now I'm ready to find tangent. Tangent theta, remember tangent is going to be opposite over adjacent. So opposite is square root 2 over adjacent, which is square root 2. So your answer in this case is actually 1. Okay, so let's go ahead and take a look at example 2. With example 2, it means cosine of arcsine 5/13 means find the cosine of the angle whose sine is 5/13. So just, I mean, if you need to make sense of it, that's generally how you will refer to as. Okay, so let's go ahead and draw the angles and whatnot. So here I have opposite, hypotenuse, adjacent. It's given to you that cosine is going to, or excuse me, arcsine is going to be 5/13. And so with this, I'm just going to use the same, we're done with example 1, but I'm just going to use the triangle here for example 2. So cosine is adjacent over hypotenuse, which is going to be a 12/13, or actually, I'm sorry, hold on a second. Arcsine, so we're working from the inside out. Let's take a look at this part right here. So from sine, it is going to be your opposite. In this case, is 5. Hypotenuse, which is going to be a 13. And so you need to find your adjacent. So your adjacent is going to be the square root of 13 squared minus 5 squared. So that's 169 minus 25, which gives you 144, and that gives you a 12. All right, so then with that said, now you could look at the cosine. Remember, cosine is going to be adjacent over hypotenuse. So what is your adjacent? 12. What's your hypotenuse? 13. So your answer is 12/13. Okay, example 3. Go ahead and pause this one and do this one on your own. Example 3, if you will have to reread this, its intention is to say find the secant of the angle whose tangent is 3x. So then take a look at my work and check your answers with mine. All right, let's go ahead and now take a look at example 4 to 8, which is going to be on derivatives of inverse tangent functions. So example 4, find the derivative of y equals arc sine x, and there are the steps. Okay, so then looking at this part right here, number 1, take the sine of both sides. And so I'm going to put sine y equals sine arc sine x. Well, your sine y stays as is, but your sine and arc sine cancels, and you just have x on the right side. So then let's go ahead and draw a diagram to see where the other lengths will be. Here's your theta, and you're looking at it from the perspective of sine, which is opposite, hypotenuse, adjacent. And think of this as x over 1. So sine is going to be opposite. That's x over adjacent, or over hypotenuse, which is 1. So then what is your adjacent going to be? Remember, your adjacent is going to be the square root of hypotenuse squared minus opposite square. So that's going to be 1 minus x squared. And that's going to be your adjacent. Okay. Step 2, differentiate implicitly. So the derivative, and this is step 2, of sine y is going to be cosine y. The derivative of x, and because you did the derivative of y implicitly, anytime you find the derivative of y, you have to put a dy over dx. Derivative of x is just going to give you a 1. So let's go ahead and find and solve Step 3, dy over dx. So dy over dx means you have to divide by cosine y, so that's 1 over cosine y. And what does 1 over cosine y can be written as? Secant y. Step 4, rewrite the right side of the equation in terms of x. So you have secant y right here. Now, what is that y equal to? Remember how in the very beginning you put y equals arc sine x? So your dy over dx is equal to secant, replace that y with arc sine x. And then, of course, you will have to repeat the example that you just did from examples 1 to 3. Okay, and so we are going to start off with sine x, because arc sine x. So you're going to draw your diagram here, which is the same diagram what you have right there. Okay, I'm going to start off with this. And remember, you're looking for secant. So what is secant going to be? Well, secant is going to be, remember, cosine is adjacent over hypothesis. So secant is hypothesis over adjacent. So that's h over a. Going back to here, what is h? H is 1. What is a? A is square root of 1 minus x squared. And that right there is your answer. Okay, so this one right here is going to be the, I don't know which one's actually the more difficult part, but this is the implicit method. Now I'm going to show you guys the other method of doing this. So you could use your formula and you could say let u, and in this case, we're going to let u just be x, okay? Then your du is 1 dx, so your dx is obviously equal to du. So then remember your derivative of arc sine u is going to be u prime over square root of 1 minus u squared. So your u prime is going to be 1 square root 1 minus u squared, so 1 minus x squared. And guess what? These are exactly the same answers. So this is the same as number 4 if you would have used the implicit method. Okay, let's take a look at example 5. For example 5, go ahead and use the implicit and then use the derivative rule. So go ahead and pause the video and repeat what you just did for example 4 by solving dy over dx. Go ahead and take a look at my answer. You should have a 1 over square root of 1 minus x squared. Well, hold on a second, that's not correct. There we go. 4 over 16x squared plus 1. Okay, if you're done with this, now I want you to go ahead and apply the derivative rule and see if you can do the derivative rule and see if you have the same answer as this answer right here, because you should have the same. Take a look at my answer right here when I apply the derivative rule. All right, you guys, for example 6, pause the video and give that a try. And I'm just going to show you guys the steps and the answers right there. I actually didn't do the implicit method. I just went ahead and just used the formula. All right, you guys, as always, stay safe and healthy, and I'll see you guys next time. And don't worry, we're going to be talking about this more in the future, so you'll get plenty of other practices.